First off, Paulette Epstein from the Michigan Science Center, inspiring the next generation with limited resources in an increasingly technological world.
Sorry. I don't want to talk at a microphone on a stand. All right. Hello, everyone. My name is Paulette Epstein from the Michigan Science Center. So for those of you that don't know anything about my dome, I have a Digistar 2. It's a 50-foot dome, 20-degree tilt with a Digistar 2, slide projectors, and I also have a few CRT video projectors. So I am one of those folks that does not really have a ton of resources when I am trying to plan new shows in our dome, and content is always changing. I know about 2 years ago, we in Michigan adopted the Next Generation Science Standards, or at least a version of Next Generation Science Standards. So we had to change things around a little bit with the programs that we were doing. And when we decided to do that, I kind of ran into this ridiculous roadblock of having very limited technology to be able to do new shows. So what we decided to do at the Michigan Science Center was we decided that all of our shows were going to be live shows. So they are all live now. And that allows us to really engage the audience. So is anyone out there in the same boat that I'm in? Yeah, we got a couple of people, I figured. Well, Howard, of course, is in that boat as well, because he's helping me keep my theater propped up with a stick. But so we don't have a upgrade on the horizon. I mean, it's there. It's tiny, though. So we're trying to figure out, how do we keep kids engaged when basically they can pull out an app and have, they can fly around the universe in their hands. And really there is no secret to how to keep the kids engaged. But there's a couple of things that we do particularly at the Science Center. So the shows that I've written are, like I said, all super, super interactive. So we ask questions and try to get the kids to answer. An example of one way that we get really interactive in the dome, when I bring up constellations, because I do have stick figures. Luckily, I do have a D2, so I can draw lines and sticks, or lines and dots, and that's it. But I draw the stick figure up in the sky, and then I ask everyone in the audience, what does that look like to you? Because if you go outside and you look up at the sky and you don't know what the constellations are, and you haven't been doing this for as long as we've been doing this, you're gonna see a bunch of dots. So if you ask the kids, what do you see up in the sky? I've gotten some really, really great answers about what they see up in the nighttime sky. Like Hercules is an old man dancing. And then we have Boötes, which is an ice cream cone. My personal favorite is the Canis Minor, which is, of course, the hot dog, as everybody knows, or at least we know. But we've gotten some really, really fun and creative answers. Kids really like to see rocket ships up in the sky. And, there's Cephas, which is the house, and all of that. So when they do go outside and they look up in the sky, they can remember, oh, I'm going to look for a house. That is Cephas the king. And it makes it a little bit easier for them to sort of remember what they're seeing, and it keeps them engaged and excited about what they are seeing in the dome. We also, at the Science Center, do some After Dark programs. So I stopped asking, what do you see up in the sky with the After Dark programs, and I'm sure everyone in here knows why. Yeah, so that's one of the really cool things that we can do to just keep people engaged. We also have a show that I wrote shortly after I started at the Science Center. It's called Stories in the Sky. That's what I named it, where we paint the sky different colors, And because I do have cove lighting, it is incandescent light bulbs, but I have cove lighting, so we can turn the sky green, and we can turn it blue, and we can turn it red. And the kids get really excited about that. And we blow clouds in the sky. We sing Twinkle, Twinkle, Little Star, because you don't need anything for that. And I encourage the kids to sing very loudly to drown me out, and my staff do as well. But that's one of the shows that we've sort of developed at the Science Center to keep kids engaged. We also tell stories with that one. So we bring up Ursa Major, and we tell an Ursa Minor and tell the stories of the bears. But most of you know that ancient Greek stories are not appropriate for children. So I have changed most of the stories that I tell, and actually made up a few as well, because that's really all they were doing, was making up stories. And kids really love it. I've had a lot of kids come in and tell me, that was awesome, after the show, and that's really why we do what we do. So we also make sure that we have great presenters. I think that's another secret to having good shows in the planetarium, is making sure that your presenters are enthusiastic and engaging. So I started at the Science Center a little less than 3 years ago, and when I started, all of the shows that they were doing were folks getting up, or our staff were getting up, and they were lecturing at the kids. And everyone was falling asleep. And so it took a lot of training to get the staff to be as enthusiastic as they need to be. Improv games are a great way to get them sort of out of their bubbles and presenting in a more interactive way. And we really do encourage the staff to ask questions. And honestly, like, they have more fun now doing the shows the way that I've trained them to do the shows than they did before, when they got up and just lectured at people. So not only are the kids having more fun, but the staff are having more fun too. We do use some of our resources that we have. So we use our cove lighting, which are incandescent light bulbs. I use my slide projector still. So if anyone has some Ectopro, Ectographic 3s, I can't use them. Ectopros 7020s, contact me, please and thank you, I will take them. So I am still using my slide projectors. I've actually gone through our library of slides, and I've put in some slides for events that we have in our dome. We actually had a wedding in there. We've had 3 weddings in the last year or so, and they're getting married under the pillars of creation and under the moon, because we have that at our disposal. So we're using the resources that we do have in creative ways that we may not have used them before. So we really do try and use what we do have. We also do have we've got we've got 2 Barco 708s and a Barco 909. Although I don't use them much in our regular programming, because things are not necessarily the most reliable. But when we do special events and we know they're working, then we do incorporate them in. But we write our shows so that we can use or we can do our shows with or without them. Because if you are like me and your technology is aging, 16 years old for our dome, you want to kind of think ahead and make sure that you can run things with or without the technology that you do have. So as long as we've got a star field, we've got a show, which is, yeah, as long as we got a star field, we have a show. And we can even talk about things that aren't just the stars. We can talk about the planets and what they look like and all of that stuff, even if we don't have the pictures up there, as long as you are talking in an engaging way, changing your voice, not speaking monotone, not making it seem like you're lecturing at somebody. You don't necessarily need a picture to show people what you're talking about. I.e., I have no pictures, I have no slides for this one. I thought it was a little fitting. So, does anybody have any questions?
Any questions or comments? Yes.
Questions?
You mentioned using improv games as like a warm-up. Do you have an example?
An example of some of the improv games that we do. One of the ones that I really, really like to do with, I also am in charge of the floor staff, so I'm not just in the planetarium, I'm also in the entire museum in our education department, but is using nonverbal communication. So we do a game where they all have to line up, and this only works once with your groups, but they all have to line up according to their birth date without talking to each other. And they can't they can't do that either. They can't flash numbers at people, but they try to line up in accordance to their birthday. So nonverbal communication, so that you can understand, like, okay, this is maybe what they're trying to tell me when people are asking questions out on the floor.
Paulette, we have some EctoPro projectors for you.
Yes!
So we'll talk after this.
Next time I come
paper.
home, I'll pick them up. Okay.
All right, any other questions or comments for Paulette this afternoon? All right, thank you, Paulette, appreciate it. All right, and so we'll be able, next is gonna be Sharon Shanks, of course, of IPS, the International Planetarium Society, No Dome Left Behind. So we'll get everything set up and get this ready in the next few minutes. All right, our next paper presentation this afternoon is going to be, like we said, Sharon Shanks of the International Planetarium Society. This is No Dome Left Behind. Sharon, go ahead.
I couldn't ask for a more serendipitous introduction because I'm a firm believer that planetariums do the best they can with the assets they have. And if they don't have digital, they do the best they can with their slide projectors. If they don't have slide projectors, they do the best they can with paper, with their Starball. Sorry. I was so busy writing notes that I didn't bring this up. All right. I wanted to talk to a number of people at once rather than writing it in Planetarium or on Domel or through emails to try to get answers from people. I've been hearing more and more through Planetarium that people feel left out. The major complaint is, everything in Planetarium is digital. I don't care about digital. I'll never produce a show in digital. I want to know about traditional planetariums. So this paper session's not intended to teach you. It's intended to gather information. Perhaps interested participants, do you have any Ecta 3s, Ecta 2s? It worked. to address the question of what is the role of the traditional planetarium in the digital world. Now, I'm going to do some definitions first. A traditional planetarium in the context of this discussion is a projector, a dome, and a presenter, and a laser pointer. Because if you can't show your audience what stars you're looking at, it's difficult. So by default, projector is understood to be an optomechanical of some kind. It can be shaped like a dodecahedron, as in the case of the very early Spitzes, and I think there's still one in use in Cincinnati. It can be a godochronos, or the latest Godo, but it's optomechanical. So the traditional planetarium, in the true sense of the word of what is a planetarium, is a means to project the stars, and the person to explain them. The most important aspect is the person to explain them. An updated traditional has added slide projectors. And I remember when that was the major update. You can have 32 slide projectors, as we did at Youngstown State. You can have dissolved pairs. You can have all skies. You can have panoramas. You can have wide angle. You can overload that cove shelf with projectors. That was state of the art until about, 15 years ago? Has it been that long already? I saw my first full dome in Worcester, Massachusetts. So whenever that was, I think it was MAPS. Video projector also, you could have video Argos, but that didn't project, didn't cover the entire screen. So that's like an updated traditional. A digital planetarium has added full dome of some kind, and usually has gotten rid of their now redundant slide projectors, which are either sitting in storage gathering dust or went to the dumpster, unfortunately. Digital planetariums can be divided into two categories. There's your hybrid digital, which retains the optomechanical and uses the digital projector in addition to it. And then there's the straight digital projectors. No optomechanical, and the digital is getting to the point where it may be the only projector made in the future. I think it might, no, not yet. I don't want to get into the debate of movies under the dome. Full dome's here to stay. There's something anybody can do about it. It's just like Pluto is not a planet. And there's really nothing we can do about it, but it's just a fact. Live presentations, I think unarguably, are the best presentations. If you have a capable live presenter and your business model allows it. See, there's a lot of different aspects into those movies under the dome. So, what do I want to know? Are true planetariums taking a back seat to new technology? Can there be show production in this digital age for the traditional planetariums that relied on slides? What show production can the traditional domes do? Do we really know what planetarium visitors want to see in a presentation? Do we know? Does it matter to them what's producing the content, a digital or slides? Is there a way that equipment no longer needed by digital planetariums be shared with others who need it? How do we let people know? It's communication. How do we reach the unaffiliated traditional domes that think that what we do as planetarians doesn't affect them. They're outside. So that's what I'm looking for. How do we share slide-based shows with domes that still need slides? When those companies that made those slide-based traditional shows are no longer in business, and that puts the copyright under question. And Mike Murray has dealt with that, making his traditional slideshows available for $100. You get slides and I think the soundtrack, and put it together yourself, no support. But at least it's kept the content and got it out to people. Lots of other things to discuss, but I'm looking for input. How much time do I have left?
We have 2.5 minutes.
Okay, I want to hear from you. I didn't want to talk all this time. I want to hear from you. Yes, Mr. Dan.
So helping out with Vision 2020 for the last couple of years, this is one of the things that was one of the items of Vision 2020. It was both how to handle the transition to what I would call current generation technology, but I thought very important to like include in this discussion not leaving traditional domes behind. But I think part of this discussion too is, yeah, what can those of us who are full dome producers, full dome users, give back in some way to the what you would call the traditional planetariums
Right.
in some way or another? And I think I don't have the answer, but I do think it's incumbent upon us. It's something that hopefully our professional organizations will help us do. And I think it's something that, of course, it goes beyond just content, but also into like the current discussion of what is pedagogy, how do we as planetariums meet the curriculum standards, and how can even traditional planetariums evolve beyond the star ball and laser pointer model to encompass the current science education needs of our school districts around us and ensure that we remain valuable and viable. And I think that's part of where any planetarium can help one another.
Yeah. Hands-on, would that include hands-on demonstrations with inexpensive props? Share those. A traditional dome, any dome can use those. A hula hoop or planet balls. Go ahead.
And I'll tack on to what Dan said. It's the technology may be proprietary, but the education is not.
Yes.
And if we can learn how to separate those two effectively, it's going to be so much better for planetariums around this country and the world to be able to teach better.
P-R-O-P-R for pride. Terry.
And like at the Science Center, I've tried to incorporate chemistry and biology and all of that stuff into star shows because that's really all I have left. And we've really tried to do that, and I'd totally be willing to share with anybody that's interested how we do that in our dome.
Okay, wonderful. Oh, look at all the hands. Yes, yes.
I've also learned over the years, because I have a lot of children that come from schools. They come to they go to a big planetarium, and then they have me at their school in their portable. And one of the feedback I always get is, most of them, they want to find Orion or the Big Dipper. How do I find the North Star? And they're not getting that in the full dome shows. They're getting great visuals on going to Mars and planets and things like that, but a lot of people want a star show.
So they must go to the planetariums. I was a huge believer of you get live. No matter what other reason you're there, you get live. And that always includes the basic star identification. So a real mixed.
One of the things that I think really is important is organizations like IPS and GLPA. What we need to do is to find ways to reach out to those people who don't have the resources to even attend conferences. I mean, because a lot of these small, say, high school planetariums or small school system planetariums, they don't have the resources to even come to a conference and hear this conversation or take part in it.
Right.
So we need to find ways that where there are connections between members of organizations, we have to find ways to reach out to those that really are in the greatest need.
Right.
If it's passing on equipment or developing new techniques that they can implement, even given their limited
And
resources.
that's
we
something
need
that
to-
I think
Yeah,
we've been doing all along. It's how do we get them to listen?
Yeah, well, again, how to reach out.
Yeah.
About 20 more seconds.
I've never met a planetarian ever that wouldn't be open to the idea of mentoring virtually anybody on anything. Especially, we are so dedicated to this medium that we have created, and we realize the significance and importance of it, that creating a mentoring program within IPS, I think would be really a good way of doing just this, because we all know there are planetarians out there that they don't go to conferences, they don't really are associated with anybody anywhere. And they're in schools, they're in libraries. I know of one library in particular in southern Louisiana. The guy didn't even know that there was any organizations or anybody else out there besides him. He knew there were other planetariums around, but he didn't really realize anything else. If we could find some way to reach out to these people, and through an organization that's actually a committee or whatever that's already set up, then we could help with individuals like that. And the next step, of course, is going to be hardware. From time to time, organizations are upgrading their hardware. We have planetarium machines, we have slide projectors, we have video projectors. We have shows that have been around for decades. I can speak directly to this because that's exactly the situation I'm in. I've got shows in the planetarium that date back 30 years. And we're about to upgrade everything in the planetarium, and I don't want to see this stuff go to waste. The planetarium machine itself is going to be an exhibit in the museum, but there is so much available out there that people could actually use. And I think a mentoring committee would be a good way to do that.
Unfortunately, that's where we'll have to cut off today.
So
But
see me, see Tom, so people in the back can see you. Stand up.
Tom.
Tom, all right.
All right. Well, thanks. And of course,
See us,
thank you, Sharon.
and we'll talk.
Excellent. All right. And so our next presentation this afternoon is going to be teaching about infrared astronomy with Jeff Holt of Madison Metropolitan School District Planetarium. And so we'll make sure everything gets set up. And Jeff, whenever you're ready. Ladies and gentlemen, Jeff Holt.
Good afternoon. Thank you for being here. So this, what I want to share is something that's evolved out of the outreach programs that I've done after having a chance to fly on Sophia. In NGSS, and I would guess in any state standard, there are going to be places where lights and eventually, like by the time you get to high school, electromagnetic spectrum comes in. And it's pretty, hands-on. You can do some great things teaching about visible light. But what about the other types of light that we can't see? And so this is a way that I've found to be very effective to branch out into some of those types of light that we can't see. It starts with the visible light, and then we talk about the fact that the visible light that we see, the sunlight, is all of the colors of the rainbow, and the kids do a great job of coming up with that. But there are colors beyond red, and once you say it that way, some of them say infrared, and we say, well, there are colors beyond violet that we can't see. Oh, ultraviolet, and more beyond that. And each wavelength has different properties. And we take advantage of that with X-rays. Blue light gets scattered in our atmosphere. Red light transmits through the atmosphere much better. Microwaves get absorbed by the water in our food so that we can cook it. And there are properties of objects, materials, that we can describe based on how they are affected by light or light is affected by them. So those of you that can see this material that I'm holding up, which of those 3 words would apply? Nicely done. Checking for consciousness as well. How about this one? Yep. And this one. Opaque. Yes. Yes, opaque. All right. So now that we've covered that, there are actually devices that we can build to detect types of light that our eyes can't detect. And in fact, starting at middle school on, many of the kids actually have an infrared detector that they may not realize they have. The CCDs in cell phones, digital cameras, almost all of them are sensitive in infrared. But most of them have a filter. But often the selfie camera does not. So try it with a remote control for a TV or DVD player. All I'm doing is pressing the button. You don't see that. You don't see that light at all without the selfie camera. And in fact, you don't see it with the camera facing out the other side of the phone either. If you want to go any deeper than that, though, you can now invest in what actually works out to me to be a reasonable amount of money to buy a camera where you can actually see more than just the light coming out of an infrared LED. Now, I'm going to switch to the other input here. Thank you guys in the back. I'm airplaying from my phone the Seek thermal camera is attached to the phone, and I'm gonna point that camera out around the room. What do you think are going to be the brightest objects in the infrared?
Our eyes.
Your eyes? That's what I heard. Other?
Cell phones.
All right. Let's check. You can wave, the kids do. So, you are the brightest objects in this room. I've always known you were bright. With the kids, I say, that's why your parents always tell you you're so bright. So we are actually glowing, giving off light in the infrared. And of course, once people start to see themselves, then they start coming up with ideas. And we do a couple of demonstrations, and I'll show you just pictures of those demonstrations because we're so short on time. But once we start doing demonstrations, then the kids start saying, well, what if I put water on my face? What if once we establish the fact that what we're seeing is the warmth, what if I put an ice cube on my face? What if I rub my hands together? What does a television screen look like? And so they start coming up with all kinds of great experiments. And of course, I even had my students take the camera around, and cafeteria is a great place to take the infrared camera.
Can we try that with the lights out?
Sure, if they don't mind. It is actually, if you can turn off the lights. Anybody know how to turn off the lights? Because what happens is they're thinking, well, maybe it's a reflection. So it's actually most effective if you can get it in a planetarium or a dark room, because then you see that, yes, you guys are the light source. Oh, and it's actually good that you got me to switch back inputs. And I should show that some of you have insulation on your head. Some of us do not. The other kids like that. All right, so let's go back to, we're not going to switch inputs yet, but let's go back to our properties here. See if I can do this and hold the microphone at the same time. So what did you say that this material was? Yeah. Or, let me try to get, oh, I have to do it like in front of somebody. All right, so you hold it in front of yourself. And put it up in front of your face. Not only is it what? Opaque to infrared light, but if you look carefully, you can even see my reflection.
Oh, that's creepy.
Wait, who just said that? Hey, Patty, we're going to talk. All right, so that's opaque. Grab the opaque material here. Just for time, we're going to skip translucent. Put your hand inside there. It's actually kind of like a mitten. All right, and we have. So you can even hold up 2 fingers. You can see that it's real time. It's not like warming up the bag. We're actually seeing that this opaque material in visible light is actually transparent in the infrared. Okay. And that's just contractor bag. These are just like sheets of Plex that you can get at a hardware store. All right, switching back to the PowerPoint. So I have the kids put their hands on the wall and then take their hands away. You can see the heat signature left behind. Take their shoes off, walk on the floor, you see their footprints left behind. They love that. And then you apply this to your car in a parking lot in the summer. Visible light, glass is transparent, infrared, opaque. That's why the car gets so hot. That's how a greenhouse works. That's how greenhouse gases work. Apply this then to understanding the universe around us. If we only studied the universe in visible light, look how much we would be missing. The kids actually gasp. And we talk about the fact that planets, clouds of gas and dust like this, they are emitting energy in the same temperature range as like us. So Stratospheric Observatory for Infrared Astronomy, SOFIA, they have a 2.5 meter telescope. It's a partnership between NASA and the German Space Agency. So why would they go to all that trouble to put it on an airplane that is an unstable platform? Well, it's because infrared does not transmit through our atmosphere very well. So it's a 747 modified, so that it's got that garage door, and there's a bulkhead there between the cabin area where the people, scientists are operating, and now you'll see the garage door open. Bulkhead keeps the air and the people from rushing out into the clouds. Instrument goes right where those technicians are, and the instruments can be changed out. And I will tell you that I had such a good time on these 2 10-hour flights that my smiling muscles were tired at the end. I thought that was a good gauge. And of course, we have another way that we should be teaching about infrared astronomy coming up with the James Webb Telescope. All right, so I hope this helps you to see that there are ways that we can teach about the type of light that we can't see.
All right, thank you, Jeff. Any questions or comments? Questions or comments? Yes.
For your phone, was there an app that you used for the infrared? And is it like a free app or something you purchase, or what's
Free app, yep.
What's it called?
Seek Compact. If you just do a search for if you're on Android or iOS, just do a search for like Seek Thermal, because that's the name of the company for this. The other one was, I'm not sure how it's pronounced, but it's FLIR. Yep, they make the cameras, and then they would have the apps too.
All right. Excellent. Well, thank you, Jeff.
Thank you.
For a fantastic presentation. All right, next up is Mr. John Elvert on the art and science of celestial cartography. We'll get everything set up and begin that presentation. All right, ladies and gentlemen, John Elvert.
Thank you, Michael. Again, good afternoon. I think this might be a little different of a paper on astronomy education, but it's still applicable in classrooms and in the planetarium as well, I think. At least for me it has been. As most of you, I got fascinated with the nighttime sky when I was little. And that fascination eventually led to a career in the planetarium field or astronomy. I also, in my fascination for the nighttime sky, later became very captivated in the way the nighttime sky was presented in books and manuscripts. And eventually this interest developed into a real dedicated hobby in collecting antique maps. This, for example, is a 1730 map from John Flamsteed that I have. So what I noticed, though, over time was that there are objects on maps, earlier maps, and especially in the 17th, 18th, 19th century, that depict the nighttime sky that are recorded to have stars that really are not stars. So I'd like to, in this presentation, take a look at some of the recorded stars that are not actually stars at all. Let me also say that these earlier maps were the kind of the cutting edge of observational astronomy when they were made. And again, the renaissance of the golden age of map making was in the 17th, 18th, and 19th centuries. It's kind of like the Salone Digital Sky Survey today. I mean, these were really maps that represented the nighttime sky, and many times other astronomers referred to these maps. And you probably know that Charles Messier, a French astronomer in the mid-1700s, was a very avid observer of the nighttime sky looking for comets, and he bumped into all these other non-comet objects. And today we know a lot of these objects to be galaxies and nebulas. So something similar. I'm going to refer to John Flamsteed. Again, kind of a 17th century astronomer. He was actually the first royal astronomer, and he was actually the first accredited astronomer that did maps, celestial maps, using a telescope. So his maps became very accurate, and actually Isaac Newton and Halley actually used some of these maps for their studies and calculations. The maps are very picturesque, of course, but what these astronomers, especially John Flamsteed, not only depicted the constellation figures like this and recorded the stars, but what accompanied these star maps were volumes of very detailed descriptions of the star charts, kind of like right ascension, declination of exactly where these stars were and what they were. So this is a page out of John Flamsteed's catalog in 1729. After he died, his wife published his map making. And actually, he didn't want any of his maps made, and actually it was Isaac Newton and that wanted to use his maps, and he actually, Newton got permission from Flamsteed to use some of the data on some of these maps. And when Flamsteed found out that he actually used all of his data, he got so ticked off that he collected almost the 400 copies that were actually printed, and took 300. He couldn't find all 400 copies. He found 300 of them, took them in his backyard, and burned them all. He was that pissed off. So these are very rare, actually, or the originals were. But this is a 1729 page, and it shows Taurus and obviously Orion there. A little close-up view, however, you can see the ecliptic going across the sky, and we see the Pleiades, and we see this object here in particular. I'll point this out here. And on closer observation here, we'll see that that object that was right below the ecliptic is not a star at all, but was actually the planet Uranus. Now, I use the virtual planetarium software, Stellarium, and I went back to 1690 is when, in December, is when Flamsteed made that observation and put that object in his star catalog. So got the date and month down there to show you that this is what the sky looked like when Flamsteed sort of did that observation. And this is that little double star I just showed you there. So this is a way to kind of confirm some of the interesting objects that were on these earlier charts that are not really on the charts. Another Flamsteed chart was Cassiopeia. And this is, Cassiopeia has a couple of interesting objects, but one in particular is the object right down here. It looks like it's in the constellation of Cepheus, but it's not. The Flamsteed numbers, by the way, were not invented by Flamsteed, but by a French astronomer in 1781 by Joseph Lalande. So the object today in the sky is not a star, but is actually right here. And if take a look at that through a telescope, that was probably a supernova. This is a Chandra image of that object. And working this time back to the explosion, it was probably around 1667 and visible to John Flamsteed. So that star does not exist today. This is the strongest radio source in the nighttime sky. There are a number of other cartographers, astronomers that did the same thing. This is another French astronomer, mid-1700s, Alain Mallet, and he came up with a lot of interesting objects that were supernova. This is, in fact, 5 constellations that had supernova at the time. There's Cassiopeia and Cygnus, Andromeda. Cetus, actually, this star here is not a supernova, but is what? Anybody know? Yeah, it's the variable star Mira, the wonderful. So just time crunch-wise, this is another example in the Cygnus of a supernova. But I wanted to point out this that was recorded as a supernova, but is not a supernova. It's actually M31 in Andromeda. So as a follow-up, how to use this type of information in the classroom? Well, this is kind of the art and science connection. I actually brought in some of my antique maps when I started doing this into the classroom or planetarium. Never do that again. So you can go online and get all kinds of these earlier star maps and use them to show students the connection between art in the sky, these elaborate decorative forms of constellation figures, and enhanced appreciation of their perspective on how earlier people saw the universe and their place in it. And also have used this in a kind of a citizen science research and trying to get people who are interested into looking for objects using these earlier star maps, objects that are not stars but are other objects, deep sky objects as well. And it's been somewhat successful, but I thought that using star charts in the classroom to help students identify not only constellations, but the storytelling as well, and the appreciation of earlier peoples and the artistic approach to the nighttime sky. Am I out of time? Yeah, sorry, thanks.
All right.
Okay.
Thank you, John. Any questions or comments? All right. Mr. Hotstep. John, we need the microphone for the streaming, so we'll...
Hey, John, we have an old star map at the planetarium that's always been assumed to be a reproduction, but a couple of months ago when I really started looking at it, maybe it's not, and I wanted to find out if there's a way I can find out what the truth is about that. If there's some way to analyze it to find out if it's authentic or not.
Yeah, that's always a question for me when I purchase maps online. There's a guide actually to how to make sure that they're authentic. And I could talk to you, but there's a website, actually, a couple of websites and auctioneers that primarily deal in antique maps, and they actually can verify whether it's authentic or not. And you have to be careful because you can get ripped off.
So we have, in our library, we have a collection, as it turns out, of star maps, a beautiful, beautiful collection. And we had a partnership with the library on campus, so they could tell me about the cartography and the style, because I didn't know about 17th, 18th century bookmaking, and I could tell them things about the maps themselves. So it was a wonderful opportunity to kind of enhance our understanding on both sides. So especially if you have any connections with libraries either in your community or your campus, that's a great way to bring different kind of people to the planetarium.
Yeah, the historical side there.
And then John?
So if Flamsteed did not put the numbers on his star charts, I know he came up with Flamsteed numbers. You say Lalande was the first one to actually put them on charts?
Right. He actually, in 1781, decided to reproduce Flamsteed's charts. And he produced them in a smaller, these are huge charts. They're like 2 feet by almost 2 feet. And so that was another downside of using these astronomical charts, is because they became very unwieldy to bring them outside and try to look at the nighttime sky. So he republished Flamsteed's charts in a smaller format, and at that time decided to actually label the numbers after Flamsteed. So it was some years later that occurred. Thomas?
Okay. The nice thing is, on Monday we had in our planetarium in Hamburg the International Map Collectors Society. It is very interesting. So there's this IMCOS, is the abbreviation, is the acronym, and very interesting to do that, putting up digital high-resolution scans we did on the dome. And they were thrilled. And also then I took them into the 3D map of the digital universe in the end, and they were in stereoscopic, even with 3D glasses, immersive, so they were blown away. So I think it's very important, that connection of connect people. It's about location, 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 as we always say. The planetarium is about location, locating us on a map of the universe and in the history of the universe. So this is a wonderful element. I can only enhance what you're saying, how important it is for us planetariums. And I'm planning to embrace that, and I want to really connect with you, with your experience in historic maps. So we should continue with that. And
yeah, if there were more time, I have done that. I've actually turned this slide into a full dome. And so you bring up the nighttime sky, and then you crossfade to something like this, and then you actually, as you said, you fly out into it. So.
Well, that'll be our time for you, John. But thank you so much. Thank you so much. And then our last presentation of the afternoon is going to be Mike Murray, And Mike will get you all set up for his presentation, Beyond the Show, the full planetarium experience. And from the Delta College Planetarium and Learning Center, Mike Murray.
Thank you, sir. Hi, everybody. Hey, it's great to be here. I hope everybody's enjoying it. This has been a really great experience. There's been so many conversations that I'm really glad to hear about, all the varied ways that we're using our planetariums now, especially in light of the digital revolution and what we're all trying to do to stay connected with audiences, to stay relevant with the curriculum that we're doing, to stay connected and to be able to help inspire. And so I was fortunate enough to get into the Clark Planetarium in Salt Lake City in 2002 when they were making their transition. This isn't Salt Lake, by the way. If anybody's from Boston, thank you for letting me steal your slide. Thank you. Just want to give credit where it's due. So the thing that's so fun about what has happened with planetariums and being able to become truly dynamic, yes, those tools are great, and it's allowed us to look at many other ways of utilizing the space and even becoming more cinematic in a lot of cases. However, just because it opened up those opportunities, in some cases it also allowed for this temptation to be able to put so much of our time and effort into the creation of video playback. For a while anyway, and I know this happened with us when I was in Salt Lake, it almost allowed for the temptation to fill the entire planetarium experience with all of this great high-resolution playback. And that was all fun, but we also very quickly started to realize, how is this affecting our audiences? How are we staying connected with them? Are people just coming in and feeling like this is just a movie in the round? And so we had to really kind of take a closer look, and we've had a chance to explore this a lot in Delta College at the planetarium there. In fact, Gary Beckstrom, my predecessor there, was already doing a lot of this as well. The idea that you can still take a lot of what the planetarium has to offer in real-time experiences and live interactive experiences and put the two together. It's not about one or the other or how much, is one any better than the other. To me, it's sometimes apples and oranges, but it's also a way of how do you maintain that unique character of the planetarium and stay connected, have that human element in connecting with your audiences. So a few things that we've really started to practice and perfect. We're always working on trying to improve this, and I've heard some great ideas here at this conference in terms of, what do you do when you first get people oriented to your program? Well, first of all, we want to get away from that old classic of standing somewhere back behind the audience at that console and going, "Hello, welcome to the planetarium, and here's our rules and regulations. Now shut up and enjoy the show." No, obviously you want to get out there, make sure you get in front of your audience, and make sure that you have a way of really connecting the passion and enthusiasm and interest that we all have and finding ways to transmit and connect that to your audience. And so being able to do a really good, genuine introduction is one thing, but there's more to it. With some of the programs, especially if you're talking about experimental content, things that are even non-astronomy or cross-disciplinary, it's really important, we found, to prepare the audience for what kind of experience that's going to be. Because most people, no matter what the title of the show is, are coming thinking that they're going to get something about the stars, the constellations, and space. And so if you're going to be trying something that's a little different, we like to be able to take a little bit of time to prepare them with some examples. And one of them is like, I call it the prologue, where with some shows you can actually create some visuals to go along with your audio description of, okay, what is the topic and how are we going to be approaching it? And that way people are going to be at least a little more open-minded, hopefully, in terms of what it is they're going to be getting. You're getting a context. And so I found, especially with some of the experimental things that I've tried over the years, that it made a huge difference. I was literally asking people, we want your feedback. We want your ideas. What did you think was good? What did you think could have been done differently, or whatever kind of language you want to use, depending on the audience that you have. So afterwards, now I know a lot of people like to put their constellation or their current events, hot topics element at the beginning of their show, and that's fine. I think a lot of it is a matter of taste and what kind of community you have. In our case, we spend the opening with just a short, the intro and the prologue, and then we save the last 15 minutes of the hour for doing the current nighttime sky. And we don't spend too much time on this. We want to make sure people do at least get a few things to orient themselves and a few things that are new in their sky for them to go look at. But it's an opportunity for us to tell them about the live shows that are completely live, about observing and telescopes, binoculars, whatever. We have some special programs that focus on that. And this gives them at least a little flavor. But this also gives people an opportunity to see that, yes, every single show we do has something about the nighttime sky. And beyond that, we also want to make sure we include something about the hot topics and current events. What I love about having a digital facility is how quickly you can incorporate, how quickly you can respond to things that are going on in the world of space and astronomy and other related sciences for that matter. And people just love it when you can say, oh, by the way, this image came down from New Horizons yesterday, or the Hubble Space Telescope. And when you can respond, and especially in ways that make use of the dome, not always just square images. In fact, we like to try to find as many ways as possible of taking advantage of that immersive environment so it feels unique in as many ways as you can. And when I talk about some of these live add-on elements, I mean, they can be in all these different forms. It can be maybe short full-dome video clips, but it can also be things you pull up out of your system. Do you want to say, oh, here's the Pleiades, and oh, by the way, here's a three-dimensional trip. We're going to just go ahead and zoom right out to it. People love that. Unexpected. The things that you can surprise them with, we find is very engaging and entertaining. And isn't that where learning really happens? So we find lots of different ways of doing this. Content can come from so many different sources, whether it's out of your system or from NASA. There's great science visualizations, of course, that are available now. And the connection to the domes, data to dome, there's lots of things happening there in terms of being able to bring in content that works well in the dome. And in many cases, we also like to even add some experiences that are just pure fun. Some of you are probably familiar with the Space Park 360, the roller coaster rides, and of course, lots of kids, they'll come at the end of every show, they're like going, I want to see the roller coaster. You choose, and you pick up and pull up the buttons and such. So there's lots of ways of being able to add bonus experiences. And again, just to remind you, again, the kinds of content we want to put on the dome, we don't want to just have it feel like a slideshow. Whenever we can find elements that can immerse audiences as much as possible, we do that. You guys know what FRIS means, right? Floating rectangles in space? Yes. So we try to make sure that it's rehearsed. We want to make sure that it comes across as feeling very genuine and enthusiastic. The kinds of surveys and the kind of responses we get from people have been phenomenal. More people stick around at the end of the show to ask questions. And really, remember, isn't really the goal that you want them to feel excited enough to want to go out and learn more on their own? So it's really, that's when I think, again, to the planetarium as being, as Don Hall would say, the inspirational device. We're more interested in them going out and feeling like they'd want to go and learn more on their own. And when we're marketing and pushing the planetarium and advertising, we like to be able to use those elements in all the things that we do. Is that, by the way, when you come to see a program at the planetarium, with every show we do, I do this in our radio shows and our blogs, that there's always this added element, the added content. So, how are we doing? 30 seconds. Oh, there we go.
All right. Thank you, Mike.
All right.
Any questions or comments this afternoon? Anyone? All right, Mike, I think you're off the hook.
Whoa.
With that, we are 7 minutes ahead of schedule. That ends us for this session. And then next up should be a IPS invitation.
Oh, I did have one last thing if we have just a moment.
He's got time.
There is a video. One of the things that I do in our introductions that I love is when I'm illustrating how the planetarium full dome experience is different from the flat screen experience. I didn't want to just throw an image immediately. This is an example of what I call expand the frame. And it's a way of saying, here's what the flat screen might feel like up in the front, like in a traditional theater, but what if you could literally, there we go, and we gradually swallow the audience. And every single time we do this in our introductions, there's oohs and ahs, because it's like they get it. It's not just going instantaneously from one to the next. It's letting them feel it completely go around them. And so it's one of the best ways in our introductions to get them used to the idea of, look, it's almost like a collective VR experience. You don't have to put on the goggles. You don't have to get the 3D glasses. Just, you're a part of it. And so this was very powerful. Anyway, glad we had time for that. Thanks.
And we do have about a minute left for a question, Chair.
I'll ask the question everybody's asking. How do we get that?
We created that at our place. I got permission from Robin Sipp because that's out of the program Life Under the Arctic Sky. But if I can get his permission, I have the frame masters. I can send it out as long as he's okay with that.
Anything else?
Oh, there it is.
Excellent.
Thank you,
All right.
guys.
Thank you, Mike.
Appreciate it.